Here we are importing libraries like NumPy, Pandas, Matplotlib, sklearn, Keras, and TensorFlow. After this, we are loading our data set from Google Drive, and we are unzipping the file. And after we are creating a labels, here we have created labels of potato early blight, potato healthy, tomato early blight, tomato late blight, and tomato healthy. Just for references, we are creating a data frames to show the name of the picture, disease ID, and disease type. Now we are configuring our data. For example, potato elibelite is taking a disease ID of 0 and potato healthy is taking disease ID of 5. Next, we are drawing our plotting a histogram. Here we can see 0 type of images. 0 type of disease have 1000 images, and coming to second type of disease we have 250 images, like so on. For just for references, we are showing the images of tomato healthy in 5 cross 5. These are the images of tomato healthy 5 cross 5, and we are creating some helpful functions in order to resize and read the image. And we are normalizing our data by dividing all the images with a picture of 255. And we have classes of 6, so we have mentioned number of classes equal to 6. Now we are going to split our data into training and testing data. Here 80% of data is goes to training and 20% of data goes to testing. As we can say, test side says is given is 0.2, that means 20% of data is test size. And here we are showing the data of images after normalizing. So as we can see, our potato late blight and tomato early blight and tomato late blight. And we are setting our hyperparameters, that means epochs equal to 50 means we are going to train our model, and we are going to pass our training data 50 times, and the size equal to 64 means we are giving a batch size of 65, and channels equal to 3 months red black red RGB colors. And here we are building our model using densnet function. We are using global average pooling, batch normalization, dropout, and batch normalization, dropout. Here we are doing 2 times batch normalization and dropout to get more accuracy. And here we used a softmax function in the output layer. That means it will predict the classification of the disease. And here we have given loss equal to categorical class entropy. That means we are here we have category, it's like tomato healthy, tomato late blight, tomato early blight. So here we have like category, so that we took the loss equal to categorical entropy, and we are returning our model. After that, we are training our model with some checkpoints. Here I have some fixed checkpoints, and we have given a patience equal to 10 minutes. That means 10 times if our model does not improve, then it stops training. And we took a verbose equal to 1. That means it will show that the value is improved from this much to this much. And here we have trained up to 50 epochs. As you can see, we have trained up to 50 epochs, so that we got an accuracy of 0.986 and loss of 0.034. That means very low loss. And we have evaluated our model using, we have stored that our model into model new dataset H5. And our confusion matrix is this. That means one disease plant and the other disease plant does not mix with each other. That means our model is predicting correctly. And coming to model complexity graph, our model accuracy is 98.3%. That means, as you can see, for training and testing data, our model accuracy is too much high. And coming to model loss, a model loss for training and testing is low, so that we can say that our model is learning perfectly for each and every disease. Now here we are going to do real time testing, so that we are importing all the importing functions. And after, we are connecting our Google Drive, so that here we want to choose the file. Here I have to choose a file from tomato late blight, so that it will predict that the tomato late blight. As you can see, we want to choose another image, so that I am running this line of code. Now I have to choose the file. It's take time. As you can see this code until that time. Here we are uploading our image. After uploading our image, we are making grayscale equal to false, means we are not changing any color, and we are changing into target size. As we can see, disease classes have 6 labels. So potato early blight, potato late blight, potato healthy, tomato early blight, tomato late blight, and tomato healthy. And we are reading this image, and we are expanding our image, and we are normalizing image by dividing to 55 pixels. Now our model used to predict the given image, so that it will predict the name of the disease along with the index. So I am choosing a file. So as you can see, in previous I have chosen a file from tomato late blight, so that I got the output of tomato late blight. Now I am going to choose from tomato early blight, so I have chosen this image. Now it's open. Next it should predict the output. So just wait for few seconds to get the output. As you can see, potato early blight, as we have chosen a image from the potato early blight, it had predicted a potato early blight. That means our model is working very fine with 98.3% accuracy with CNN algorithm. That's all about this project. Thank you.